Hello everyone, myself Viren Patel, associated with LJ Institute of Engineering and Technology. So in this current video lecture series, we are studying subject of Physics Group 1. So in this chapter of laser, we have learned about its properties, principle and Einstein theory. In last video, we have discussed the basic concepts like lasing, population inversion, metastable state and pumping. And also we have discussed the basic laser components which are used in lasers. Now, in this video, we are covering the topics such as ruby laser and HENE laser. So let's start with ruby laser. So ruby laser is first successfully developed in 1960 by Mayman. So ruby is a crystal of aluminum oxide in which few aluminum atoms are replaced by chromium atoms. The chromium atoms have metastable states which are used for lasing action. Now let's see the construction of ruby laser. So here you can see in the figure the end faces of a ruby rod in the form of cylinder are polished flat and parallel. One of the end faces is completely silvered and other is partially silvered. The ruby rod is surrounded by a helical xenon flash tube as shown in figure. This flash tube provides optical pumping. So here we can say that the optical pumping is used as a types of pumping. Here the ruby rod is placed in a glass tube through which a liquid nitrogen is circulated for cooling as very large amount of heat is produced. Now let's see the working. Intense flash of light is produced by xenon flash tube. The chromium atoms in the ground state absorb this light and are raised to a wide band of energy levels as shown in figure. The mean lifetime of atoms in this state is very small. Some atoms from this energy band jump back to the ground state where some drop to intermediate metastable states. Here the metastable states are E3 and E4. So a very intense flash from the xenon tube produces population inversion in these states where the mean lifetime is a few milliseconds. The transition of atoms from E2 to E3 and E4 is a non-radiative as this energy is converted into vibrational energy to the atoms in the crystal. Now, some atoms in the state E3 emits photons spontaneously by falling to the ground state. So some of these photons which travel along the axis of resonant cavity produce stimulated emission due to which intensity of light builds up along the axis of cavity. So the laser is transmitted through the partially silvered surface. Each flash of light from the xenon lamp is used to produce a pulse of laser. Hence, this ruby laser is also known as pulsed laser. So, the ruby laser is a high power pulse laser in the visible region, but the efficiency of this laser is very low. So, here you have to keep in mind for that operation that some of the atoms in state E3 emit photons spontaneously by falling into the ground state. Some of these photons which travels along the axis of resonant cavity produce stimulated emission due to which intensity of light builds up along the axis of cavity. So the laser is transmitted through the partially silvered surface. So here each flash of light from xenon lamp is used to produce a pulse of laser. Now let's discuss the helium neon laser. So helium neon laser is also known as HNE laser. It is a type of gas laser in which a mixture of helium and neon gas is used as a gain medium. So let's discuss what is gas laser. So gas laser is a type of laser in which a mixture of gas is used as the active medium. Gas laser are most widely used laser. Here the HENE laser are most commonly used in college laboratories, whereas carbon dioxide laser are used in industrial applications. The main advantage of gas laser over solid state laser is that they are less prone to damage by overheating, so they can be run continuously. Now let's move towards the detail of HENE laser. So at room temperature, ruby laser will only emit short burst of laser light. Here each laser pulse occurring after a flash of pumping light. So it would be better to have a laser that emits light continuously. Such laser is also known as continuous wave laser. So HENE laser was first continuous wave laser ever constructed. It was built in 1961 by Elizabeth, Bennett and Harriot at Bell Telephone Laboratories. Now, in HENE laser, the optical pumping method is not used, but here electrical pumping method is used. So we can say that the excitation of electrons in HENE gas active medium is achieved by passing an electric current through the gas. Now let's move towards the helium neon laser construction. So here the helium neon laser consists of three essential components: pump source, gain medium and resonating cavity. So we will discuss that three components in detail. So let's start with the pump source. In order to produce the laser beam, it is essential to achieve population inversion. Now we know that population inversion is the process of achieving more number of electrons in excited state, or we can say that in higher energy state as compared to the lower energy state. So in general, lower energy state has more electrons than higher energy state. However, after achieving population inversion, more electrons will remain in the higher energy state than lower energy state. So in order to achieve population inversion, we need to supply energy to the active medium. So different types of energy sources are used to supply energy to the gain medium. In ruby laser and ND-YAG lasers, the light energy sources such as flash tubes or laser diodes are used as pump source. But here in case of HENE laser, light energy is not used as pump source. Here high voltage DC supply is used as pump source. So high voltage DC supplies electric current through the gas mixture of helium and neon. Now let's discuss the gain medium. So here gain medium is made up of mixture of helium and neon gas contained in a glass tube at low pressure. The gas mixture is commonly comprised of helium gas. Therefore, in order to achieve population inversion, we need to excite primarily the lower energy state electrons of the helium atoms. So in HENE laser, neon atoms are active centers and have energy level suitable for laser transitions, while helium atoms help in exciting neon atoms. So here electrodes, anode and cathode, are provided in glass tube to send the electric current through the gas mixture. These electrodes are connected to a DC power supply, as you can see in the figure. Now, let's discuss the third component, that is resonating cavity. So the glass tube is placed between two parallel mirrors. These two mirrors are silvered or optically coated. As we know that each mirror is silvered differently. Here the left side mirror is partially silvered and it is also known as output coupler, where right side mirror is fully silvered and is known as high reflector or fully reflecting mirror. So the fully silvered mirror will completely reflect the light, whereas the partially silvered mirror will reflect most of the light but allows some part of light to produce laser beam. Now let's discuss the working of helium neon laser. So in order to achieve population inversion, we need to supply energy to the gain medium. In HENE laser, we use high voltage DC as pump source. This high voltage DC produces energetic electrons that travel through the gas mixture. The gas mixture in HENE laser is most comprised of helium atoms. So when the power is switched on, a high voltage of about 10 kilovolt is applied across the gas mixture. So this power is enough to excite electrons in the gas mixture. So the electrons produced in the process of discharge are accelerated between the electrodes through the gas mixture. Now, in the process of flowing through the gas, the energetic electrons transfer some of their energy to the helium atoms in the gas. So as a result, the low energy state electrons of helium atoms gain enough energy and jumps into the excited states, or we can say that excited states are also known as metastable states. So let's assume here the metastable states are F3 and F5. You can see in the figure. So these metastable state electrons of the helium atoms cannot return to the ground state by spontaneous emission. However, they can return to the ground state by transferring their energy to the lower energy state electrons of the neon atoms. So the energy levels of some of excited states of neon atoms are identical to the energy levels of metastable states of helium atoms. So let's assume that these identical energy states are F3 is equals to E3 and F5 equals to E5. So E3 and E5 are excited states or metastable states of neon atoms. Now, unlike the solid, a gas can move between the electrodes. Hence, when the excited electrons of helium atoms collide with the lower energy state electrons of neon atoms, they transfer their energy to the neon atoms. As a result, the lower energy state electrons of neon atoms gain enough energy from the helium atoms and jumps into the higher energy states like E3 and E5, whereas the excited electrons of helium atoms will fall into the ground state. So here we can say that helium atoms help neon atoms in achieving population inversion. Similarly, the ground state electrons of neon atoms are excited to the metastable states. We know that metastable states have longer lifetime. Therefore, a large number of electrons will remain in the metastable states and hence population inversion is achieved. After some period, the metastable states electrons of the neon atoms will spontaneously fall into the next lower energy states like E2 and E4 by releasing the photons, and this process is also known as spontaneous emission. The neon excited atoms continues onto the ground state through the radiative and non-radiative transitions. So it is important for continuous wave operation. Now, the photons emitted from neon atoms will move back and forth between their two mirrors until it stimulates other excited electrons of neon atoms. So, the optical gain is achieved, and this process of photon emission is also known as stimulated emission of radiation. So, the light or photons emitted due to the stimulated emission will escape through the partially reflecting mirror, or we can say that output coupler, and similarly they produce laser light. Now, let's discuss the advantages of helium neon laser. So, it emits laser light in visible portion of spectrum. It has high stability and low cost. It operates without damage at higher temperature. There are some disadvantages like they have low efficiency, low gain, and they are limited to low powered tasks. Now, helium neon laser has variety of applications in industries, in scientific instruments, and in college laboratories. So this is about helium neon laser. In this video, we have discussed the UV laser and the helium neon laser. Now, in next video, we are going to discuss the applications of laser in material processing, welding, and cutting. So that's it for today's session. Thanks for watching.